This example is talking about the seniors and how they scored on last year's Unit 1 test in Mrs. McNally's second period advanced algebra class. It says that they had a mean of 79% and a standard deviation of 6. So part A just says label the normal curve for the set of data. So our mean goes in the middle, 79, and then we're going to add 6 going to the right and subtract 6 going to the left. So if I added 6, I would have 85, then 91, and 97. And if I subtracted 6, I would have 73, 67, and 61. So that takes care of part A. It says what percentage of students scored below an 85. So the first thing I want to do is I want to label my percentages, right? So remember that each side, if you go 1 standard deviation away from the mean, is 34. If you go 2 standard deviations away, you have 13.5%. If you go 3 standard deviations away, you have 2.35%. And then beyond that, each of them is 0.15%. All right, so now we can actually look at what percentage of students scored below an 85. So below 85, I would be talking about everything. So here's 85. I would be talking about everything to the left. So I'm going to highlight everything that is to the left of 85. So all of those numbers that are highlighted in that yellow section are what I need to add to get my answer for part B. So I would be adding, I'll just start from the left, 0.15 plus 2.35 plus 13.5 plus 34 plus 34. So if I add up all those percentages, I get 84%. So that means 84% of the seniors scored below an 85%. Part C asks what percentage of students scored above a 67. So I'm going to erase the yellow and I'm going to highlight now in a light green color. So here is 67. And I want to add up all of the things that are above 67. So now I'm talking about everything to the right of that number. So I'm going to be adding up 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. So if I add up all of those things, I get 97.5%. So that means that 97.5% of them scored better than a 67%. Now this last part is where things are hopefully going to make a little more sense as to what this whole lesson is about. It says what percentage of students scored below an 80. So up until this point, we've been able to always identify the number that we're trying to find the percentage above or below. It's been one of our numbers that are on the horizontal axis. But if you look here at my numbers, 80 does not exist. It would be somewhere in here because I know it's between 79 and 85, but I can't say exactly what the percentage is because my number doesn't fall exactly on 1, 2, or 3 standard deviations away from the mean. So this is where the z-scores come in. Z-score allows you to calculate what the percentage is above or below some number without it having to be an exact standard deviation away from the mean. So this part D, we cannot do this yet because 80 is not one of our numbers. So that's where this z-score stuff is going to come in. So we'd have to use a z-score. A z-score is the number of standard deviations from the mean that a data point is. So up until now, everything has always been an exact 1, 2, or 3 standard deviations away from our mean. But now what we're going to be able to do is find 1.75 standard deviations away from the mean, and we'll actually be able to figure out the percent even though it's not one of the percents that we have memorized. So there's 2 parts to this. The first part is we have to actually calculate what the z-score is, and then the second part is we're going to use that z-score and we're going to use our z-score table to actually calculate the percentage. So the first thing we're going to do is just focus on how do you find a z-score. So here's the formula. It's up here in the top right. This formula you do not have to have memorized. It will be given to you on both the unit test and on the final exam. But you do need to know how to use it. So to find the z-score, you take the value that you're trying to find the score for. So in our previous example, we were trying to find 80. So that would be our value, minus the mean divided by the standard deviation. So let's take a look at this first problem. It says find the z-score of 85. So I would do my value, which is 85, minus the mean. And remember that we're going back to the previous problem. So the mean is 79. That part was already given to us. And then it told us that the standard deviation was 6. So if I do 85 minus 79 divided by 6, and you can put this in your calculator, it's going to give you 1. And if you think back to the previous slide where we had our bell curve, and I'm going to draw kind of a quick picture here. Our mean was 79, and 85 was right here. It was 1 standard deviation away. That's why the z-score is 1, because it was 1 standard deviation to the right. If I wanted to do the z-score for 67, that was another one that we figured out. So the z-score for 67 would be 67 minus the mean, which is 79, divided by 6. And if you put this in your calculator, you're going to get -2. And remember that 67, if you go back to the previous example, it was 2 standard deviations to the left. So that's why our z-score is -2. And then finally, getting back to that part D that we were never able to finish, if I wanted to find the z-score for 80, I would do 80 minus the mean, which is 79, and then I divide it by 6. And then if you put that in your calculator, it gives you 0.16 repeating. And because it's 0.16 repeating, we would say that this is 0.17. That would be our z-score. So you always want to round it to the nearest hundredth, which means 2 decimal places. I have a little note down here where I'm putting this purple star. You have to be really careful when you try to find z-scores in your calculator. What we just did is we found the z-score for 80. This right down here that I'm going to highlight it in orange. This is the correct way to type it into your calculator. So you have to show the calculator or tell the calculator that the 80 minus 79 goes together in the numerator and then divide it by 6. If you look at the top, that part I'm going to highlight in blue, that is the wrong way to put it in your calculator. And the reason it's incorrect is because the calculator will follow order of operations. So it will do your division first. It does 79 divided by 6. And then it does 80 minus that number. So you end up with 66.83 repeating, which is totally wrong. So just be really careful. This is a really easy thing to do, but if you're not very careful how you type it into your calculator, you could end up getting something wrong even though you knew what you were doing. All right, so then it says, now we're moving on to part E. If a student scored a 62%, how did they do compared to the other seniors? So the z-score tells you a lot of things. It tells you how many standard deviations you are away from the mean, but depending on how big that number is and whether it's positive or negative, it also tells you some information about how that person did compared to the group. So let's first figure out what the z-score is for 62%. So I would take my value minus the mean, which is 79, and then divide it by the standard deviation. So we're doing 62 minus 79 in parentheses, and then divided by 6, and it gives me -2.83. It's actually -2.83 repeating, but because I want it rounded to 2 decimal places, I'm just going to leave it like this. Okay, so this tells me a few things. The fact that it's negative tells me that somebody who scored a 62% did worse than average. So the average is 79. It tells me that they didn't do as well as most of the students in the class. The fact that it is -2.8, that's actually a pretty big number, meaning that it would be pretty far to the left of the mean, because remember, when you're looking at your normal curve, this is 3 standard deviations, -3 standard deviations away. This is -2 standard deviations away. So that person is like over here somewhere, negative 2.83. So compared to the rest of the class, they actually did quite a bit worse than everybody else did. So your z-score can tell you both if they did better or worse than average, and then it can tell you how much better or how much worse, depending on how big that number is. Okay, so there's a little note down here that says that we still haven't answered what percentage of students scored below an 80%. So we figured out the z-score, but we haven't actually found the percentage. So that's where we're going to go next. I want to say one more thing about the normal curve before I move on, and that is, and I think I kind of mentioned it already, but I just want to make sure it was really clear. So if you have a z-score of 0, that means that you are exactly at the mean. If you have a positive z-score, it means that, if we're talking about test scores, for example, if your z-score was positive, it would mean that you did better than average. If your z-score is negative, it means you did worse than average. And then, you know, for example, a z-score, like if you had a z-score of 0.2, it would mean you did a little bit better than average. But if you had a z-score of 2.5, it would mean you did quite a bit better than average. All right, so now we're at the point where we're going to talk about percentiles. Percentiles are a number that tell you what percent of the data falls below a certain value. And we're going to use our z-score table to find these percentiles. So in relationship to our example that we've been talking about, feels like forever now, we're going to use the z-score for 80% to find the percentile. So I just want to refresh your memory. We did the z-score. We did 80 minus 79, and we divided that by 6, which was the standard deviation. And we rounded it to 0.17. So that was our z-score. Now your z-score table is a double-sided table. One side is for positive z-scores. The other side is for negative z-scores. So what I've done is I've just snipped out just the part of the z-score that we need, so that you can see how you figure this out. So you're going to do two things. We're always going to have a z-score that is 2 decimal places. And the reason is you're going to look at the first number behind your decimal point. So that's 0.1. You're going to look on the vertical axis that goes on the left side, and you want to find the matching number. So my first decimal place was 0.1, so I found 0.1 on my z-score table. So what I'm going to do now is I'm going to highlight this entire row. Now the second number, I'm going to take that number, which is 0.07, so I know there's a 1 there, but it's like a 7, and I'm going to find that 7 up here on the horizontal part of your z-score table. And then I'm going to highlight everything going down. And you'll notice that there's one spot where a number got highlighted in both yellow and blue, and that would be this number right here. So that number would be the percentage that corresponds with our z-score. So we want the decimal 0.5675. Now that is not the percent. That's a decimal that corresponds with our percent. In order to find our percent, what we're actually going to do is multiply this by 100, but the shortcut is when you multiply by 100 that you just take your decimal point and you move it twice to the right. So this is actually 56.75%. So this percentage now tells us that there are 56.75% of students who scored below an 80%. Now, one thing that is kind of tricky about z-score percentiles is that when you look at your z-score table, it always tells you the percent less than your value. So if you look at this picture up here, so like this z right here, this was our 0.17. And then the percent less is the thing that's shaded. So if I wanted to find the percent more of something, we're going to have to do an extra step. And we'll talk about that in some upcoming examples. The mean height of Major League Baseball players is 73.5 inches with a standard deviation of 2.25 inches. So the first thing we want to do is find the percent of Major League Baseball players who are shorter than 72 inches. So if I'm talking about them being shorter than 72 inches, that means that I need to look for the percent that's below, which is exactly what a z-score will tell you. Now, one thing I do want to point out, this is something that can be a little bit confusing. Right now, you know that we're finding z-scores because that's what this lesson is all about. But when you look at your test review and when you're getting ready to take your exam, what's going to be confusing is that all of these problems are going to look the same. You're not going to know when you need to use a z-score and when you can just use the percentages on the normal curve. So I want to show you how you would tell that you need to use a z-score, even though you already know that you do. So what you would do is you would set up your normal curve, and you would you would write in your mean, and then we would figure out the standard deviations. So if I take 73.5 and I add 2.25, I would get 75.75. If I add 2.25 again, I get 78. I'm kind of running out of space here. And then 80.25. And then I'm going to do the same thing going to the left. So I'm going to be subtracting 2.25 now. So this is 71.25. Then I have to subtract it again, and that gives me 69. And then the last one would be 66.75. All right, so here's how you would tell. It's asking me to find the percent that are shorter than 72 inches. And if I look at all of the numbers on the bottom of my normal curve, 72 would be like here somewhere, but you can't actually see the number 72. So when you fill out your normal curve and the number you're trying to find doesn't exist on your normal curve, that's how you know you need to use a z-score. All right, so let's figure out what that z-score is. So I take my value, which is 72, minus the mean, which is 73.5, and I divide by the standard deviation, which is 2.25. Remember that you need to be careful plugging this into your calculator. Make sure you use parentheses or do something so that the order of operations are followed properly. If you do that, you're going to get negative 0.6 repeating, which we are going to round to negative 0.67. Remember that you always want your z-scores rounded to 2 decimal places. Now we have to find the percent. So I've snipped out the part of the z-score table that we want. Because our z-score is negative, you have to make sure you're looking at the negative side of the z-score table. And I'm going to look at my first decimal, which is negative 0.6. So I know I want this row right here. And then my second number is a 7. So I want to look at the top here, and I want to look at all of the things that are underneath the 0.7. And then I'm focusing in on the part that is overlapped by both blue and yellow, which is 0.2514. Okay, so that is telling us our decimal, 2.2514. And then in order to change that into a percent, I move my decimal over 2 times. So it would be 25.14%. So that 25.14% of Major League Baseball players are shorter than 72 inches. In this next example, we are now looking for the percent of players who are taller than 76 inches. So I want to draw a quick picture down here. I already know that I'm going to use a z-score, and we talked in the last example about how you know whether or not you need to use a z-score or if you can just use the normal curve. So I'm looking for the percent that are taller than 76 inches. I'm going to put the mean on here, which is 73.5. I know that 76 is going to be somewhere to the right of that. So this is what I'm actually looking for, is everything that is to the right of 76. The catch is that if I use the z-score table and I find the percentile, the answer it's going to give me is what is to the left. So here's how we're going to do this. We're going to find our z-score for 76. We're going to find the corresponding percentage. That percentage is going to be the percentage represented by the green X. When we're talking about data, when we're talking about this normal curve, if I looked at the entire normal curve, that represents 100% of my data. So if I figure out what is represented by the green X and I subtract it from 100, it will leave me with this part right here, which is what I want. So there's just one extra step at the end. We do everything the exact same way, but then once we find our percentage, we subtract it from 100, and that gives us what's above our value. So let's start by finding our z-score. So our z-score would be our value, which is 76, minus the mean, divided by the standard deviation. When you enter this into your calculator, you're going to get 1.1 repeating, but remember that we want 2 decimal places, so I'm going to do 1.11. Now I go to my z-score table. So the first thing I'm going to do is look for my first decimal. So I want 1.1, so I'm going to highlight this whole row. And then my second number is also 1, so I'm going to find 0.01 at the top, and then I'm going to highlight everything going down. And then the part where they overlap, which says 0.8665, that's going to be my decimal. Now I'm going to take that and change it into a percent. So I move the decimal over twice, and I have 86.65%. But remember that this is not our answer. This is telling me the percentage of players who are shorter than 76 inches. So to find the percent of players who are taller than 76 inches, I'm going to do 100% minus 86.65%. And that's going to give me this yellow section that I have highlighted down at the bottom. So if you do 100 minus 86.65, it gives me 13.35%. So that means that 13.35% of Major League Baseball players are taller than 76 inches. For this example, we're going to do something a little bit complicated, so I'm going to try to draw a picture down here. We're trying to find the percentage of players who are between 70 and 74 inches. So here's the mean, 73.5. And I'm trying to find players who are between 70 and 74 inches. So I want to know what's the percentage in between. Remember that your z-score table, when you figure out your percentile, is going to tell you the percentage below. So if I find the percentage that is below 70, it's going to give me this part that's in yellow. If I find the percentage that is below 74, it's going to give me this part that's in green. So what I'm going to do is I'm going to find the percentage of the green part, which is going to use the z-score for 74. Then I'm going to find the percentage for the yellow part, which I'll use a z-score for 70. And then I'm going to subtract the two, because if I take the green part and then I subtract away the yellow part, I will only be left with the orange part, which is what I want. So we're going to have to do 2 z-scores, 2 percentages, and then we're going to subtract the 2 of them. So the first thing I want to do is find the z-score for 74. So z-score for 74 would be 74 minus the mean divided by the standard deviation. When you type that into your calculator, it gives you 0.2 repeating. So since I want 2 decimals, I'm going to say it's 0.22. Next, we need to find another z-score. This time we're finding the z-score for 70. So I'm going to do 70 minus 73.5 divided by 2.25. When you put that in your calculator, you get negative 1.5 repeating. So I'm going to say this is negative 1.56. All right, so I have 2 z-scores. Now I have to find their corresponding percentages. So for the percentage of, I'm going to do the blue one first. My first decimal is 0.2, so that would be this line, this row. And then my second number is 2. So I'm going to look for the column that has the 2, and I'm looking to see where they overlap, which is right here at 0.5871. So 0.5871, and if I change that to a percent, it would be 58.71%. Now I have to do the same thing for the other z-score. So the other z-score was negative 1.56. So negative 1.5 is right here. And remember that you have to be looking at the right side of your z-score table. So for that first z-score, I was looking at the positive side. Now I'd be looking at the back side, which is the negative side of your z-score table. My second number is 6, so here's the 0.06. And the part where they overlap is right here at 0.0594. So if I change that into a decimal, into a percentage, it would be 5.94%. Okay, so I have my two percentages. Now I need to subtract them. So I'm going to take 58.71%, and I'm going to subtract 5.94%, and that's going to give me the percent of data, or the percent of baseball players who are between 70 and 74 inches tall. So if I subtract those two numbers, I get 52.77%. So 52.77% of Major League Baseball players are between 70 and 74 inches tall.